Okay, so we are on 2-4 day 1, and you will have a 1-problem quiz on this process that you learned today when we get to it. So the last section we talked about measures of central tendency. That was the one number that described the set. And they were mean, median, mode. Now we're going to talk about measures of variation. And I'm going to give you 2 data sets, and these are going to be starting salaries at 2 different corporations. We'll go Corporation A and Corporation B. And then the numbers I give you are going to be in thousands of dollars. Okay, we're going to make this a Corporation B over here, Corporation A over here. We're going to put them back to back in a double stem and leaf. So we got salaries that start in the $20,000 range, 30, 40s, and $50,000 range. So the lowest starting salary at Corporation B is going to be $23,000. Then we got a $29,000, 32, 40, 2 41s, a 49, a 50, 52, and 58. Corporation A, the lowest one is 37,000, 38, and a 39. We've got 3 41s, a 42 and a 44, a 45 and a 47. Okay, just a question first to start with. If you had to pick which corporation you could work for, and these are starting salaries, which one would you pick?
For starting salaries?
Yep, these are starting salaries.
Corporation A.
Why would you pick A? Better chance of getting, because you're pretty much guaranteed something between 37 and 47. That's a good starting salary. Anybody want to pick B? Because there's really no right answer. This is kind of a personality question. What kind of person would pick Corporation B? A risky one. So a gambler. Boy, let me see. I can start out making $58,000. We're over here, I'm going to max out at 47 for my starting salary. So if you're real confident in yourself and you're a wheeler dealer and you can talk them into a high salary, maybe you'd pick Corporation B. But you might end up down here too. So when I asked you which one would you rather work for, that's a total personality question. There's no right or wrong answer here. But are these 2 data sets the same? What's the biggest difference about them? How spread out they are, right? These are all clumped together. These are spread way out, and you use one of the words we're going to get to. But I do want to compare the mean, the median, and the mode salaries for both corporations. So let's have the Fornhoffs do Corporation A, find mean, median, and mode. You can put them into a list like we were doing earlier, and then you 2 do Corporation B, mean, median, and mode. And then we'll go mean, median, and mode. I can get the modes done for you. Mode is 41,000. And 41,000. Yeah, you could have each done one. Somebody could have done mean, somebody could have done median. Did you get any of them yet? Let me know if you...
For B, I got the median is 41.5,
So $41,500.
and the median is 41,000.
41,000. What'd you guys get for Corporation A? Mean, I think you got that wrong. The median you can probably count out.
Well, I did the wrong side, that's why.
Oh. Well, it was still 41.5. 2. So the median's going to be 41,000 here. Oh, recycling coming by.
The median is 41.5.
41.5 here also.
Oh my God, where's your trick class?
They're down in interviews.
That boy. Focus.
Focus.
We'll be back.
Okay, so if I was to show you, not the top part, just this. This is Corporation A, this is Corporation B, and you saw these three values, what would you think about the two data sets?
They're basically...
I think you think it's essentially the same thing, but then as soon as you see them, you can see, boy, they're not very much the same. These are more spread out. So when we talk sets of data, there's really two values we want to talk about. That measure of central tendency and how spread out the values are. And that how spread out is called a variation. And we've got three measures of variation that we're going to do. So the three, just like there were three measures of central tendency, mean, median, and mode, we've got three measures of variation. The first one, being the one Matt already said, was range. How do you think you get a range for a data set?
Take the highest subtract the lowest.
Max minus min. So if we do the range for Corporation A and then the range for Corporation B, that's where we're going to see a big difference. So Corp A, our highest salary there was $47,000 minus the $37,000. They have a $10,000 range. Corp B, what was their high? $58,000 and $23,000. That is a big range. That difference is $35,000 range. Big difference between their top starter and their bottom starter. Okay, so right there's where we see the difference between the two sets. Okay, range is not a great thing to use because think about, remember that outlier that we had? Say everything's grouped together and then we have this one low salary back here, maybe a $20,000 starter. It's going to, when we do the range there, it's going to look like they're all spread out, but they actually aren't. Most of them are clumped together, just one of them's way far away. So that's when range is not such a good measure of variation. And then we use this other technique. And this technique is what you're going to have a one problem quiz on, probably Monday. So, and it is called variance. We're going to do population variance and sample variance. So population variance. And there's a symbol for population variance, the Greek letter. It is lowercase sigma squared. And the formula to get this, I'm going to give you the formula, then we're going to go through the steps on the calculator, and these calculator steps are what you're going to have to, you're going to practice them on the homework today, and that's what your quiz is going to be on. You're going to be adding up. you're going to take each data value, so we'll call it an x value, subtract the mean of the set. These are called deviations. It's how far away each value is from the mean. This is called a deviation. You're going to take each of those differences and square them. That's what you're going to add up. After you subtract and square, you're going to add up all of those squares. Then you're going to divide by the population size. And we can kind of streamline this process by using the lists on the calculator. So that's what I want. I'm going to write down the steps, and then we're going to actually do it. So the first thing, let's write it and do it at the same time. So I'll turn this on. Well, it's going to be these are going to be the steps. And then we'll put the answer down afterwards. So the first thing you're going to do is you're going to put your data values into a list. So enter data into a list. So again, let's do half and half. Well, this isn't plugged in. If you've already got them in there, just give me a second and I'll catch up. I'll do Corporation A. So remember how to get there, stat, edit, clear that out. So I got 37, 38, 39, 42, 44, 45, 47. Okay. Then you want to find the mean of your list. And you remember how to do that? You want to quit, go into list, math, mean of list 1. So it was 41.5. Oh, they're back. And now you want to find the deviations. And this is where we can make the calculator do all the work for us. What you're going to do is go to L2. So go back to Stat, Edit. Clear out L2 if there's numbers in L2. Go all the way up on top so that you're on L2. And now I'm going to say, take all my x values are in list 1. So I'm going to say, take list 1, L1, and then subtract, what am I subtracting? 41.5. And when I hit enter, it will do those 10 subtractions like that. So L1 minus whatever mean value you found in step 2. So now I've got all of the deviations. So I've done the each x value minus the mean. What do I want to do next with these numbers? According to this formula up here. We want to square each of those differences. So we're going to square the deviations. Again, we can go to list 3 now. Go over, go up, clear it out if it's not clear. What are you going to tell it to do? Square list 2. Take list 2 and square it. It's just a little time saver. Could you do all these on a little dinky calculator? Yeah. Take you a long time? Yeah. So this is just a handy little tool. L2 squared. Okay, so squared them all. So what do we do with all of our squares? We want to add them up. So this is where we're going to go back to list, over to math. So quit, get out of list 3, go into list, which is above stat, over to math. Which one's going to help you out there? The sum. What do you want to sum up? Everything in L3. Okay. What's your last step? Yep, take the sum and divide by the population size. So what was our population size? I think we had, what, 10 data values in each one? Okay, so our example here, we'll write down the answers, and I want to talk about the units on this answer. So, the variance for Corporation A, I got 8.85, and that would be thousands of dollars, not quite thousands of dollars, we're going to talk about it in a minute. What about the variance for Corp B? It should not have been the same. Did you guys run through with B? Rachel, did you have B done? What? Did you have B? Did you go through all this? No? Matt, did you do B? Ah, jeez. What do I have in my notes?
Run through it again.
Yep, go ahead. See if you can follow those steps. Because this is what your quiz is going to be on, these 6 steps here. So if you want to practice B, go ahead and do B. See what you get. Because I do have the answer written down. So even with the list, it still takes a few minutes to crank through one of these. By hand, I think you'd probably more than double your time, because you have to do what you're doing almost 10 times. Probably take you about 3 or 4 minutes a problem, I would say. Maybe 5. What'd you come up with? 110.25. Everybody good with that? Okay, I want the units on here. Let's go back and think about what the units are. If I go back through the formula, X was the number of dollars, thousands of dollars, but still dollars. The average was dollars. So if I take dollars and subtract dollars, I've still got dollars. Then I squared that. What am I at now? Dollars squared. Mean anything to you? No. No real life meaning for dollars squared, but that's what we're at, dollars squared. Then I add up dollars squared plus dollars squared plus dollars squared, still gets me dollars squared. Divide it into some chunks. The units on these 2 answers right here are dollars squared. That has absolutely no real life meaning to anybody, dollars squared. But it is an indication of how spread out things are. The bigger the number, the more spread out. The smaller the number, the closer they are. So, but most times when you do variance, you're going to get units that don't mean anything, like this. So how do I get out of dollars squared? What could I do to get rid of dollars squared? Square root. And when you square root this answer, you create what's called population standard deviation. I don't know if you heard of standard deviation before, but that's the one that's the value that's most often used with data sets is standard deviation. So population standard deviation is just the square root of population variance so its symbol is going to be the square root of sigma squared, which is going to give us sigma. So the standard deviation for Corporation A would be the square root of 8.85. $2.97 thousands of dollars. We're back to just dollars now. The standard deviation for Corp B square root of 110.25, $10.5 thousands of dollars, so $10,500. And what this is really telling us is it's the average distance away from the mean. So both of these are giving us the average distance from the mean. So the smaller the number, the closer everything is to the mean. The bigger the number, the farther away things are from the mean. It's more spread out. Okay, so that is one other thing today. Remember, most times we talked about the population's too large to gather, so we work with samples. The formula changes slightly if you're working with a sample instead of a population. So, and these aren't as long as the rest. So,
Third way,
nope. It's just it's range, variance, standard deviation, but then it's population versus sample. So, but we're not going to change much. So sample variance the symbol is S squared. Its formula is very, very, very similar to the population formula. You're going to add up all of the differences squared. The difference is right here. We don't divide by the sample size. We divide by the sample size minus 1. Why? I don't know. So this is sample size minus 1. Where if you have a population, so it's going to tell you in the problem whether you're working with a population or a sample, so you know what to do on the very last step. So the 6 steps, well, the 5 steps are going to be the same. Put them in a list, find the mean, find all the deviations by subtracting, square them all, add them up. It's the last step that changes. If it's a population, you divide by exactly how many data values you had. If it's a sample, you subtract 1 and then divide. So then sample standard deviation is just the square root of that answer. And that is what I have for you today. Your assignment. Stats 2-4. Page 78. One through 4. $10, $12, $16, and $18. Well, you should be able to finish this easy.